So today's lesson is going to focus on writing linear equations, and a lot of this is going to be review from Algebra 1. So first we need to talk about the different forms of equations, and up until this point we've been working with the y equals mx plus b slope-intercept form. And this is our most useful for graphing, but it's not the only equation. Another extremely useful equation for writing the equation is called the point-slope form. And this is great when you know a point and you know the slope, or if you know 2 points, because you can find the slope. And this one says y minus y1 is equal to m times x minus x1, where x1, y1 are a point on the line, and m is still a slope. The key with this formula, and the thing that kids forget, is that in order to have an equation, you need variables. So this y and this x are variables, and you never replace them with a value. You always leave those as variables. But there are actually 2 ways to do a problem like this. So first, write an equation in slope-intercept form. The line that has a slope connected through the fifth and passes through this point here. So the first way we could do this is we could use the point-slope form. Now remember, if a point passes through the line, there's a point on the line. That means it satisfies the equation. It means it makes the equation true. So I can substitute this x and this y into my slope-intercept form and solve. So what's going to happen is I'm going to take, and I know the slope. I happen to know a y and an x on this line, and then I can solve for this and write my equation. So it looks something like this. Negative 2 is equal to negative 3 fifths times 5 plus b. You can see at this point, here's my point on, here's my slope, here's what I don't know. So when I solve this, I have negative 2 is equal to negative 3 plus b. Add 3 to both sides. 1 equals b. Now I can take this and my slope value, and I can write y is equal to negative 3 fifths x plus 1. And that represents all of the points for that line, all of the equation that gives you all the solutions essentially of that line. Now another way to do it is to go ahead and use this point-slope form. So I have y y minus y1 is equal to m times x minus x1. So what I'm going to substitute at this point is I'm going to replace this and this with my point that's on and my slope. And so I'm going to have y minus 2 is equal to negative 3 fifths times x minus 5. Now this isn't in a very usable form, so I'm going to go ahead and do the distributive property over here. 2 is equal to negative 3 fifths x plus 3. I'm going to subtract 2 from both sides, and I'm going to have y is equal to negative 3 fifths x plus 1. And I got the exact same answer. It's really the same amount of work. I personally find the point-slope form the easiest to use, but this first method here also works. So let's go ahead and do another one. Write an equation in slope-intercept form for the line that has a slope of negative 3/2 and passes through negative 4/1. I'm going to use the the point-slope form, because I think that one is the easiest. So again, I need to leave those generic x and y values, and I'm only going to substitute the ones that I've highlighted. And so I have y minus 1 through xy is equal to negative 3 halves times x minus 4. I take negative 3 halves times 4 over 1, cancel, cancel, up with negative 6, add 1 to both sides, y is equal to negative 3 halves minus 5. And that is your equation of the line that goes through 4, 1 and is a slope of negative 3 halves. Now, what is the equation of a line passing through 2 points? So given 2 points, I can still use my point slope form because first, we find the slope. And that's a formula. So subtract my y's over my x's is negative 10 minus a minus over 5. So my slope is negative 2 over 1. And then I'm going to use and 1 point. And it doesn't matter if I use this one or this one. I will get the same answer. You will get the same answer as your neighbor. So I'm going to use y minus y1 is equal to x minus x1. Again, only replacing those 3 places. So I'm going to use this one just because it's first. Y minus minus 3 is equal to negative 2 over 1 times x minus 2. Distributive property. The minus is plus. Y plus 3 is equal to negative 2x plus 4. Subtract 3 from both sides. Y is equal to negative 2x plus 1. That is the equation of the line that goes through those 2 points. Now, what if I had a real life problem such as this? Sales of 300, she made 78. So this really a couple of ordered pairs. And if you think about in general, your salary to a sales job would be equal to your total salary, would be equal to your daily plus your commission. Commissions are going to be a percent of your sales. Okay, so this is a real life situation. So what happens here, and if you notice in our graph, our sales is our X value, our total salary is our Y value, independent and dependent. So this gives me the order pairs of 158 and 378. So I could plot those 2 points. 100 at it is about there, and 378 is about there. But we need to come up with a situation with dart and compass. This is just like the previous example with 2 points. First, I'm going to find the slope. 8 minus 78 all over 100 minus 300, which is going to be negative 20 over negative 200, which reduces to 1. That decimal. You can either use a fraction or the decimal. We typically talk about slope in terms of decimals, or fractions, not decimals. Now I'm going to use that point slope form. 1 as x minus x1. That is going to become, and again, you can use either point. Y minus 58 is equal to 1/10 x minus 100. You end up with y is equal to 1/10. What does this mean? What is her daily salary and her commissions? This equation gives you both of those. The y-intercept, where it crosses the y-axis, is where she starts at 0 sales. That's her daily salary. $48 because she's had 0 sales, she makes 48. And is the slope. And now 1/10, that's not, we don't talk about 1/10, we talk about percents of commissions, and 1/10 is really 10%. And so that is her commission. She gets 10% of any sales, and that is how her line like sells. For every bit more she sells, she gets a steady increase in her money. Notice how much would she make if her sales were $500? And now if we want to do this, sales is our X value. This is X, and we want to know what Y is. So we take our Y equals 1/10 X plus 48, and we're going to substitute what our sales are. So Y equals 1/10 plus 500 plus 48. 10% of 500. Y equals 50 plus 48. The total salary will be $98. And that would correspond, if her sales were clear out here at 48, you can see in that area of the graph. Now, parallel and perpendicular lines. And remember, parallel lines have the same slopes. Those aren't particularly interesting. Remember, perpendicular, the slopes are opposite reciprocals. So your equation still works. You just have to remember to do that opposite reciprocal. So I'm perpendicular to this line here. My original line is -5. That means the slope of my line perpendicular is going to be the reciprocal, 1/5. The opposite sign was negative, now it's positive. Now this problem is just a general point slope problem. And the only thing I have to worry about is to use this slope. So I have y minus -2 is equal to positive 1/5 times x minus 3. Y plus 2 is equal to 1/5 x minus 3/5. Subtract 2, subtract 2. Y is equal to 1/5 x. Got some achy fraction work here. -3/5 minus, change -2 to something with a common denominator. 10/5 minus 13/5. That is your equation of a line. That's the end of today's lesson. Oh, one more. If they are perpendicular, forgot one more example. Very similar, my slope here is -4. My slope perpendicular is positive 1/4. Right to form derivative property. 3. That's the equation of the line perpendicular. Now I'm done with the lesson.